All right, welcome everybody. Let's do this. So graphing factored polynomials. What does this look like? If I were to have this polynomial over here, and I were to say, hey, graph this, your first instinct would be to just put it in the calculator and graph it. And yes, you can do that, but let's say if we don't have a calculator, what properties of this polynomial determine how the graph looks like? And that's what we're going to figure out. These are very important properties. So let's go through all of them, okay? So I'm going to zoom out a little bit, and let's go through each one of them. So the first one, let's find the zeros of the polynomial. If I have some polynomial, let's see, x minus 3, x plus 3, and x minus 1, if I want to find the zeros, right, I just make it equal to 0, and then let's look at this. X minus 3 equals 0, x plus 3 equals 0, and x minus 1 equals 0. So here I know x is 3, x is minus 3, and x is 1. Okay? Easy peasy. So when I graph this polynomial, I know that it has to hit at 3, negative 3, and also at 1. It has to hit those 3 points because they represent the zeros of the polynomial. Okay? Now let's look at this part, the multiplicity of each zero. Well, notice, what are my zeros? The zeros are 3, negative 3, and 1. And what the multiplicities are talking about is, if I look over here at this part of my polynomial, notice what is the exponent of each one of these. You see this x minus 3, what's the exponent over here? It's just 1. So the multiplicity of this 3 is just 1. Oh, whoops, hold on. Wait, let me camera angle. Okay. What about this binomial over here, x plus 3? What's the exponent here? It's a 1. So the multiplicity of the minus 3 is 1. And this one as well. It's just 1 for all 3 of them. And here, what determines if the graph bounces at this point or goes through? Here, it'll bounce if our multiplicity is even, and it will go through if the multiplicity is odd. So here, if we look at the multiplicities, they're all 1. So they're all odd. So I know that my graph has to go through the points. Okay? And let's look at the next part. It says the degree of the polynomial. If I look here, what would the degree of this polynomial be? It would be 3. Okay, why would the degree be 3? Because here we have an x to the 1, an x to the 1, and an x to the 1. Whenever I finish up the multiplication, at the very end I should get x cubed. So then the degree is 3. If the degree is 3, that means it's odd. And what's the leading coefficient? It's positive. So now we know that it's odd positive, so I know my dance move has to be this one. It has to be odd positive. So I know that my end behavior has to look something like this. So if I know that this is the dance move for this graph, our graph should look something like this. So we start here, right? And notice that this is the ending of the polynomial, right? So we start this here, but then the question is, if I have this point, do I bounce or do I go through? And the idea is that I go through for 3, negative 3, and 1, because the multiplicity was odd for each one of those zeros. So here, I go through, then I have to come up, I go through, and then I have to come down, and I go through. So we know that this graph has to look something like this. So let's take a look. If we put it into the calculator, and now here, if I hit y equals, let's take a look at this polynomial. And if I hit graph, and notice, let me see if I could change the light a little bit. No, this is good. All right, let's see. Is that better? Can you see with the glare? Crap. Okay, maybe this is there, right there. Okay, now that looks good. Now notice that this picture is the same here, and we determined it without a calculator. You see how they go through? Let's say if we had something like this. Now let's look at this polynomial. This is the polynomial that we originally have for the question, which is right over here. What if I were to change the multiplicity to 2? You see here, these two polynomials are the same, but look at the multiplicity for the minus 3. It's 2. How do you think this graph will change compared to this one? If we hit graph, notice that it's going to bounce at this point 3. Okay, because here, what is the 0 for this x minus 3? The 0 is 3. So then it has to bounce at that point. Okay? Let's try and take a look at a practice problem together, and then we will be done with this lesson. So here, let's look at this one. Imagine if I had this polynomial over here. Here, what are my zeros? Well, my zeros are x minus 3, x plus 3, and x minus 1, right? I say it's equal to 0, equal to 0, equal to 0. So my zeros are 3, minus 3, and 1, okay? Now let's take a look here. What are the multiplicities of each 0? So here, because this is the binomial for this 0, my multiplicity for 3 has to be 2, okay? What's the multiplicity for the minus 3? It's 3. And what's the multiplicity for the 1? It's 2. And notice that here, 2 is what kind of number? It's even. So we know that if we graph this polynomial, these are my zeros, right? This is 3, this is minus 3, and this is 1. Because it's an even multiplicity, I know that there has to be a bounce. Here, it bounces. Where else does it bounce? It also has to bounce over here at 1 because this is even, right? So here, it bounces at 3 and at 1, but where does it go through? It has to go through at 3 because, I'm sorry, at minus 3 because this is odd. All right, so it bounces at these two zeros and it goes through here. What's the degree of this polynomial? Well, this becomes 2, 3, 2. So this just becomes degree is 7. But 7 is odd. And what's the leading coefficient for this polynomial? It's positive. So I know my dance move has to look something like that. Okay? So once I graph this, let's see. I'm going to start over here. When I get to this point, look, this is 3, right? And this is 1, and this is minus 3. See, once I get to 3, it has to bounce because it's even. So then I go up, but then I go down, and then here at 1, it has to also bounce again, but then I'm going to go up, and then when I get down to minus 3, it has to go through because it's odd. All right, so our graph should look something like this with the bouncing and the going through. All right, just try and practice some of the examples in class and then go through all of these, and then you could use your calculator to check whether the graphs match what you have. But don't be dependent on the calculator to graph the polynomial. Okay, I'll see you.